Good evening everyone. So in the last session we have seen our first year short answer questions. In this session let us see our first year very short answer questions of chemistry. Okay. I have took few important questions from previous year and the concept based questions also. Concentrate on each and every topic because there is no choice in this section. So, and this is more scoring section also because this is a single line answer section and you can answer it very easily if you understand the question. So, I took a question like, what are isotherms? So you need to know the concept of isotherms here. So what is meant by isotherm? This isotherm are lines of constant or equal temperature. So mainly these isotherms, isobars, everything we represent in form of graphs. Here in the name itself we have therm, so it is related to temperature. So what we take here, at constant or equal temperatures, this is the most important point, isotherms are lines of constant or equal temperatures. These are imaginary lines drawn on a map joining places of equal temperature. So these are the isotherms. Just remember, this is related to constant or equal temperature. You need to mention this point. And next question is like this: which of the gases diffuses faster among N2, O2 and CH4? Why? So understand it. This is the concept of diffusion. So which gases diffuses fast? Which are less in weight, those gases diffuses fast. So what is given here? The N2 gas, O2 and CH4. So among this N2, O2 and CH4, which is the lightest gas, we need to calculate. In order to calculate this weight, you need to know about molecular weights. Molecular weights. So how you will get these molecular weights? From the periodic table. Remember the values of molecular weights or atomic weights of 30 elements. Atomic weights of 30 elements, so that you can answer any questions regarding this weights. So here nitrogen has 2 nitrogen atoms. Nitrogen molecule, N2 molecule has 2 nitrogen atoms. Each nitrogen is 14. So if we double it 14, this N2 is 28. The molecular weight of N2 is 28. While coming to this oxygen, one oxygen is 16. If you double it, because it is O2, it is 32. And what about the CH4? For one carbon, it is 12. For one hydrogen, it is 1. So there are 4 hydrogens, so completely it is 4. If you add it with 12, you will get 16. So this is for methane. This is for CH4, methane, that is 16. So now compare between N2, O2 and CH4, which have less molecular weight, methane. So now tell me which diffuses fast? Methane. So when this question is given, just compare it by using this molecular weight so that you can answer. Next, a question is asked in this way: how many times methane diffuses faster than sulfur dioxide? So we need to compare the diffusion of gases between this methane and sulfur dioxide and how they are related. To answer this question, we need to know the concept of Graham's law of diffusion. So what this Graham's law of diffusion states? It compares the rate of diffusions of the gases. What is there here? Methane. Methane is having formula of CH4. Sulfur dioxide is having formula of SO2. So we need to take rates of this, ratio of rates of these two gases, because which is diffusing how much times one of the gas, that is methane, is diffusing with sulfur dioxide. So if we are taking rates of CH4 and SO2 here. So if we take ratios of this as per Graham's law, what we need to do? The rates of diffusions of these gases, suppose R1 and R2 are rates of diffusions of any two gases, that is equal to the under root of molecular weight of M2 by M1. Those are inversely proportional with the square root. So we need to take the molecular weight of the second gas, that is M of SO2, with the ratio of first one, that is CH4. So this sulfur dioxide have a molecular weight of 64. Sulfur is 32 and oxygen is 16. Since there are two oxygens, 32 plus 32 completed, it is 64. And methane, we have seen earlier, it is 16. If you find ratio between these two, it is 4. Under root of 4 is 2. So twice this methane diffuses faster than sulfur dioxide. We know this methane is less molecular weight, it is of 16, and this sulfur dioxide is of 64. Obviously methane diffuses fast, but at which rate? At twice that of the sulfur dioxide, it diffuses faster. So this is the statement. Hence methane gas diffuses 2 times faster than SO2. So you need to mention, you need to write it clearly in this way. The next question, what is Boltzmann constant? So if a question is asked in this way, you need to write value of it, give its value, it is added here. If a question is asked till here also, you need to mention the value. So what is this Boltzmann constant? Boltzmann constant is defined as the gas constant per molecules. You can see here. Here this Kb is the value of Boltzmann constant, and this R, this is the rate of the reaction to the number of molecules. So if we see here, Boltzmann constant is defined as the gas constant per molecules. This R is gas constant, that is having a value of 8.3, by this Na is the Avogadro number, that is 6.023 into 10 to the power of 23 moles. If you solve this, you will get the value of this, that is the value is 1.38 into 10 to the power of minus 23 joule per Kelvin. This is the value of Boltzmann's constant. Boltzmann's constant. So this is very helpful in solving problems, but you just remember this value. 1.38 into 10 to the power of minus 23 is the value of this Boltzmann's constant, and R is the universal gas constant, and this Na is the Avogadro number. Next, here what is the next question asked? Give the ratio of RMS, average and most probable speeds of gas molecules. So these are the terms which are used to calculate the speed of the gas molecules. This RMS is root mean square velocity, and this is average velocity and most probable speeds. So we need to calculate ratio of them. So what you need to write is the ratio of most probable velocity, that is denoted by alpha, this average velocity V bar, and this root mean square velocity denoted by mu, that is root 2 is to root 8 by pi is to root 3. See this value, the exact formula of this most probable velocity is under root 2 RT by m. For this average velocity, it is root 8 RT by pi m, and this root mean square velocity is root 3 RT by m. If we find the ratio of these all three terms, we will get the common RT by m is removed and we will get the values of this one. If we substitute the values of this root 2 value and root 8 value by root 8 by pi value and root 3 value, we will get the ratio in this way: 1.414 is to 1.595 is to 1.732. So if you simplify these values, you will get a value in this way. This is the simplified ratio of the RMS, average and most probable speeds of gas molecules. So just remember this value: 1 is to 1.28 is to 1.224. Okay, next the question is, this is from the states of matter. What is the laminar flow of liquid? This is also one of the important question and repeated question. What is laminar flow of liquid? Laminar flow of liquid. So remember these terms, laminar flow. So what is this laminar flow? In liquids, a regular gradation of velocity of layers is passing from one layer to the next. Observed. This flow is called laminar flow. This is the definition. See, understand this. In liquids, a regular gradation of velocity. So how a liquids flow? Let us assume a liquid is flowing from a pipe in this way. So how the molecules of liquid flow? They are flowing in a random direction. If they flow in a random direction, they do not exhibit this laminar flow. What happens if the gradation of velocity for layers, if the velocity which the liquid flows it in the form of a layer, what happens when the velocity passes from one layer of the liquid to another layer? Then we can see the laminar flow. You can see in this pic. Suppose if you can see, same, if the liquid is flowing in this direction, if all the velocity of the liquid exhibited by the molecules will be in a particular direction, and the liquid also, the velocity of these liquids also transfers from one layer to another layer, then such type of flow is called laminar flow. You can see this clearly in the pic which I have given in this slide. If you observe it clearly, there is no it will looks like a water flow, looks like the water is not flowing, but here the water is flowing. What happens here? The velocity of this molecules in this layer are passing from one layer to the other layer. That's why the flow is stable. This type of flow which we observe in the liquids, that is called the laminar flow. You can observe clearly it in the pic. What happens here exactly is the gradation of the velocity for layers is passing from one layer to the next layer. Then this liquid exhibits the flow, that is laminar flow. In this way you need to explain it clearly. Next question. Question is asked like this: what is meant by compressibility factor? Compressibility factor, where you will observe this. You will see this in ideal gas and real gas concept. So what is this compressibility factor? This compressibility factor Z is a correction factor which describes the deviation of real gas from ideal gas behavior. So it is useful for thermodynamic. It is the thermodynamic property which is useful for modifying the ideal gas law to account for real gas behavior. So how this compressibility factor is explained is, we have two types of gases mainly, ideal gas and real gas, right? So there is no perfect ideal gas in the universe, but all the laws we have derived exactly are based on this ideal gas. We need to implement these ideal gas laws to this real gas. If we implement these laws for the real gas, there will be certain changes, and that correction factor which describes the behavior of this ideal gas from the real gas, this real gas, that correction is denoted by this Z, that is the compressibility factor. You can see this concept at the end of this ideal gas and real gas equations. So this is the thermodynamic property which is useful for modifying the ideal gas law. This modifies this ideal gas laws into this real gas laws. So this is known as the compressibility factor. So understand the concept and write the definition clearly. One of the important question. And next question. How many number of moles of glucose are present in 540 grams of glucose? See what is the question. How many number of moles of glucose? We need to calculate number of moles. So what is the formula to calculate number of moles? That is weight by gram molecular weight. Gram molecular weight. So if we calculate weight is to gram molecular weight, then we get number of moles. So what is the given chemical here? Glucose. Glucose is having formula of C6H12O6. So what are the grams? Given grams 540 grams. So given weight is 540 and you need to divide it with the gram molecular weight of this glucose. So calculate gram molecular weight of this glucose, that is 6 moles of carbon. See here, 6 moles of carbon, that is 6 into 12, and next 12 moles of hydrogen, 12 into 1, and next 6 moles of oxygen, 6 moles of oxygen, 6 into, for 1 oxygen 16. If you solve this, this becomes 180. So what is the weight given? 540 and the gram molecular weight is 180. If you find ratio, it becomes 3. So the number of moles is 3. This 3 becomes number of moles. So the number of moles of glucose in 540 grams is 3 moles. Remember this formula, number of moles is the ratio of weight to the gram molecular weight. Next question. Calculate the volume of oxygen at STP. STP is standard temperature and pressure, required to completely burn 100 ml of acetylene. So what are the conditions here? We need to calculate the volume of oxygen at STP, which is required to complete to burn 100 ml of acetylene. Acetylene is having a formula of C2H2. So first we need to understand what is the chemical reaction involved in it. What is this reaction? Acetylene is burning in presence of oxygen. It is a combustion reaction. You can see, first write the chemical equation first. Acetylene reacts with oxygen, gives rise to carbon dioxide and water. So balance this equation first. Here 5/2 moles of oxygen, this reacts with acetylene and gives 2 moles of CO2 and H2O. So if you write this chemical equation, you can easily understand the number of moles involved in it. So at STP conditions, right, the standard temperature and conditions, that volume taken for this acetylene is 22,400 ml. To burn this volume of acetylene, the volume of oxygen required. What is the volume of oxygen required? So at STP we are taking this value of as volume of C2H2. So this volume is for acetylene. We need to calculate volume for oxygen. So to calculate volume for oxygen, we are multiplying this with the number of moles of oxygen in the balanced equation. How many moles are there? 5/2. So for burning 100 ml of acetylene, the volume of oxygen requires, given in the question, 100 ml of acetylene. This is for 22,400. We'll get the value of this. For 100 ml, what we need to do? Cross multiply it. Cross multiply 100 into 22,400 into 5/2 into 1 by this value 22,400. If you find the value, then it becomes 250 ml. This much amount of acetylene, oxygen, this much amount of oxygen is required to burn 100 ml of acetylene. So first understand the question. If a question is given in this way, write the chemical equation, balance it. Next, apply the STP conditions. Next, solve the problem. So remember this, at standard temperature and pressure, the volume is taken as 2.4 liters if it is given in liters. If it is given in ml, multiply by 1000, we'll get 22,400 ml. Next question is, the empirical formula of a compound is CH2O. This is the empirical formula given in the question, that is CH2O, and its molecular weight is 90. This is empirical formula. Empirical formula is completely different to molecular formula and both are related to each other. So what we need to find? The molecular formula of the compound. What are the given details? The empirical formula, the molecular weight. We need to find the molecular formula. So what is the relation between this molecular formula and this empirical formula? This molecular formula is equal to N into empirical formula. So what we need to do here? First we need to calculate the value of N. What this N is equal to? Molecular formula weight by empirical formula weight. This value of N is molecular formula weight by empirical formula weight. The empirical formula given here is CH2O. This is empirical formula. Empirical formula is CH2O. So we need to calculate this weight. For one carbon it is 12, for two hydrogens it is 2, and for one oxygen it is 16. We'll get the value as 30. So here you can see here 30. So molecular formula weight in the question it is given as 90. To calculate the value of N, divide molecular formula weight by empirical formula weight, that is 90 by 30, that is 3. What we need to find exactly? The molecular formula of the compound. See the molecular formula here, it is equal to 3 into the empirical formula. It means 3 times the moles. If you multiply 3 here, it becomes C3H6O3. This is the molecular formula of CH2O. Okay, you need to solve in this way. And next question. Here one of the important and easy concept, that is about significant figures. About significant figures. This is very easy topic. If you practice 2 to 3 questions, you will get complete idea of this concept. See here, it is given few numbers. From this we need to find how many significant figures are present in the following. In the question, first is 0.0025. So it is 0.0025. In this there are 2 significant figures. Why there are 2? Because after decimal the zeros are not counted when they are before the numbers. So there are these 2 zeros are before the numbers. How many numbers are there at the end? 2 and 5. So they are completely 2 numbers. There are 2 significant figures for this, and for this 208, no decimals, and here 0 is also counted as significant figure. So it is having completely 3 significant figures. And next 5005, it has 4 significant figures. And next 12600. So zeros are present at the last, and there is no decimal also here. So the zeros are not counted. And how many numbers are there here? 1, 2 and 6. There are 3 significant figures. And if the number is 500.0, after point we have 10, and after the number also we have 2 zeros and a decimal. So all are counted. So there are completely 4 significant figures. And if you see for the next question 2.0034, it is having 5 significant figures because in the beginning there is a number 2 and we have 1, 2, 3, 4 and 5 significant figures. In this way you need to answer. Don't confuse. If you practice it thoroughly, you can easily answer these questions. The next question, assign oxidation number to the underlined elements in each of the following species. So this is related to the oxidation number concept. This is very useful for your competitive exams also, this concept. So what is given here? Let us take the first question. NaH2PO4. So this is the question given. So the underlined term here is P. We need to calculate the oxidation number for this P. It means we need to know the values of other elements first, so that you can answer these questions clearly. Here you can see one of the solution. Here let us take this P as X. This oxidation state of P, we are taking it as X, and oxidation state of this Na is, since it is first year group element, all the first year groups element exhibits the oxidation state of +1. There is only one Na, so it is +1. And hydrogen, it also exhibits +1 oxidation state, H plus form. So +1 oxidation state. How many hydrogens are there? 2 hydrogens, so 2 times of +1. And this phosphorus is taken as X. And this oxygen exhibits an oxidation state of -2. And how many oxygens are there? 4. So if you solve this, you get 1 plus 2 plus X of, what is this? 4 times of 2 is 8. Since minus is there, it is -8. This completely is equal to 0 because there are no, this is not a cation and this is not an anion, and there are no completely ionic terms are not there, so this is equal to 0. If you solve this question, the value of X will be +5. It means phosphorus is having oxidation state of +5. Next question, NaHSO4. Similarly, take here the underlined term is sulfur. Take sulfur as X and remaining term sodium as +1 and hydrogen as +1, and this oxygen as -2. 4 times of 2 is 8. All are equal to 0. So what is the value of X now? X is 8 minus 2. So this X becomes +6. So you need to mention the sign of this oxidation state of the final term, whether it is plus or minus. Similarly for this H4P2O7, take this P2 as X. Here you can see the question is H4P2O7. The underlined is here the P, phosphorus. So what is this phosphorus? X. How many phosphorus are there? 2 phosphorus. So 2 of X. And hydrogen, that is +1. How many hydrogens are there? 4. 4 of +1 is 4. And this oxygen, how many oxygens are there? 7. 7 times of -2 is -14. That is equal to 0. 2x minus 10 is equal to 0. So what is the value of 2x? That is 10. So x becomes +5. So the value of P here is +5. Don't stop by taking these values, simplify it and get a simplified value with the sign so that you can answer, and try to solve the remaining questions given here. H2S2O7, CaO2, NaBH4, KAlSO4 taken twice, and 12H2O, Cr2O7 minus 2. I will show you the value for Cr2O7 minus 2 because there is a minus 2 present. So if a question is asked in this way, here it is Cr2, means the underlying term is the chromium. So we are taking chromium as X, and how many Crs are there? 2. So 2 times of X plus 7 times of oxygen, 7 moles of oxygen. So 7 of minus 2, that is equal to minus 2. Why I took minus 2 here? Because on the complete term we have minus 2 on its power. If you solve this, 2 times of X and 7 times of 2 is 14 and sign is minus, that is equal to minus 2. If you take 2x value, it becomes 14 minus 2, that is 12, and this x is 6. What 6? This is plus 6. So here the oxidation state of chromium is plus 6. So solve in this way. And next, from thermodynamics, we have a question like this. What is the question? Write the relationship between Gibbs energy, equilibrium constant, and change in enthalpy. So what is the how we denote these terms? Write the relation between Gibbs energy, delta G, equilibrium constant, K, and change in enthalpy. Change in enthalpy is denoted by delta H. So what is the relation between them? First we need to see relation between Gibbs energy and this equilibrium constant. They have the relation in this way, delta G naught. This is the change in the Gibbs energy, that is equal to minus RT ln of K EQ, ln of K equilibrium. If it is for n moles, it becomes delta G is equal to minus nRT ln of K equilibrium constant. So this is the relation, and the relation between Gibbs energy and change in enthalpy, one of the important thermodynamic relation. Delta G is equal to delta H minus T delta S. Very important relation. You can also expect problems based on this relation. So this is the important, these two are the most important relations of this chapter. So you need to answer in this way. And you can see the next question. It is asked like to prove a statement. What is the statement given? All Bronsted bases are also Lewis bases, but all Bronsted acids are not Lewis acids. So here the main term is the Bronsted bases, Lewis bases, Bronsted acids and Lewis acids. So if you know the concept of this acids and bases, you can answer this question. What is given? All Bronsted bases are Lewis bases, but not Bronsted acids are Lewis acids. So we need to prove this by writing the definitions of these terms. What is this? Yes, the given statement is true, exactly true. Why? Let us see. The Lewis bases generally contain one or more lone pair of electrons. If they contain one or more lone pair of electrons. Such type of bases are called Lewis bases, and therefore they can also accept a proton. So this is the property for Lewis bases, which contain one or more lone pair of electrons, and they can also accept a proton. Hence Lewis bases also act as Bronsted bases. Bronsted bases which accepts a proton. On the other hand, let's see about acids. This Lewis acids. What are Lewis acids? This PCl3Al, Cl3Ag plus and Fe plus 3, etc. These are unable to furnish protons in solution, because these Lewis acids, what is Lewis acids? They have empty orbital which are lack of electrons. Such type of acids, such type of compounds are known as Lewis acids. But what is a Bronsted acid? Which is able to donate a proton. So they are having absence of empty orbitals, so they cannot donate a proton. That's why Bronsted acids are not Lewis acids, but Bronsted bases are Lewis bases. This is the concept. See, it is given here. Therefore they cannot act as Bronsted acids. Hence all Lewis acids are not Bronsted acids. This is the explanation. Got it? What are Bronsted bases? What are Lewis bases? What are Bronsted acids and Lewis acids? If you know this concept, you can answer these types of questions very easily. The basic question. Next question. What is given? Calculate pH. We need to calculate pH values for the below solutions. So which is 0.01 molar NaOH. So this is 0.01 molar NaOH solution. We need to calculate pH value. What is this NaOH? This NaOH, is it a base or an acid? Since there is OH, it is a base. So this NaOH is a base here. Since it is a base, we have the formula in this way. We are taking here example, we are taking it for 0.008 molar BaOH taken twice. See here, 0.08 molar BaOH taken twice. It is also having OH ions, so it is also a base. So all the terms given in the question are bases. So for the short answer, very short answer, you cannot get all these four. They may ask one of the question, one of ABCD, to calculate the pH. So here, since it is a base, its concentration is negative logarithm of OH minus ion. Negative logarithm of OH minus ion, that is it will have value of 0.016 normal. See here, this is for 0.008 molar BaOH taken twice. How many this moles are there? 2 moles of bases are there. So if you take for this question, you need to first mention the concentration of this OH minus ion. What is the concentration given in the question? This is for concentration of OH minus ion. This complete concentration is 0.0008 molar. For this is for 1 OH minus. For 2 OH minus, we need to multiply by 2. So what we get? 0.0016 molar. This is the molar concentration, not normal. So this is molar concentration. So this is for OH. In the question what is given, it is needed to calculate for pH. So if you simplify this term, simplify this minus log of 0.016, you will get in this way this OH minus concentration. You are multiplied by 2, it becomes 0.016. If you simplify this, you are taking log of, it is this value of 0.016. This can be written as 16, the ratio of 16 by, after decimal how many points are there? 4, right? 4. If you apply logarithm to this, this becomes log of 16 into log, this is the formula of log A by B, log A minus log B, right? Log A by B is, if you apply logarithm to this, log A minus log 10 to the power of minus 4, this becomes log of 16 minus 4 is brought to the front, it becomes minus of minus, this becomes 4 log 10. This is completely negative logarithm term, right? So this is minus log of 4 log 10, this is the value. This 16 is written as 2 to the power of 4, this becomes 4 log 2 plus 4. So this is, if you simplify this, this will be the value 2.796. Still this is value for P of OH itself. We need to find for pH. So what is the complete value of pH plus POH? It is 14. If you subtract the value of OH minus from this 14, you get the value of pH. So this pH value is 11.204. Similarly, you need to calculate all these terms. If you simplify this, all the terms, you will get this value. If you solve more and more questions in this way, you can answer them. So solve this type of questions. This is a little mathematics involved, but still you can do it. And the next question, what is meant by coal gasification? This is from environmental chemistry. Coal gasification explained with relevant balanced equation. So this process of producing syngas from coal is called coal gasification. This is the synthetic gas, that's why it is called a syngas. The process of producing the synthetic gas from coal, this is called coal gasification. The chemical reaction is the carbon which is in solid form is heated in presence of water in the form of gas, which gives CO, carbon monoxide, and hydrogen at 1270 Kelvin. At this temperature it is heated. So the gas produced out, that is the synthetic gas, this process is known as coal gasification. This is also easiest form and most scoring part. And next, what happens when magnesium metal is burned in air? So in air we have gases. So this magnesium will react with the gases present in the air. What are the most gases present in air? Oxygen and nitrogen. So magnesium reacts with this oxygen forming magnesium oxide. And this magnesium, how will be the reaction? 2 moles of Mg reacts with oxygen, giving rise to 2 moles of MgO. And next 3 moles of Mg plus N2, which gives rise to Mg3N2. So this is the reaction involved. And next, what is inert pair effect? Explain with an example. Most important question. Very important question. What is inert pair effect? So this is the occurrence of oxidation states 2 units less than the group oxidation state that are sometimes attributed to the inert pair effect. See here, when the oxidation state becomes less to the common oxidation group state, simply when the oxidation state becomes less, it means the oxidation state value of few elements will be decreased. That decrease in the oxidation state because of the inert pair effect. So what happens exactly in this inert pair effect is the reluctance of s electrons for participating in bonding. It means the s electrons do not participate that much freely in the bonding. Because of this, there will be the electrons will not be shared, the s electrons will not be shared with the other atoms. So the inert pair effect is exhibited. For example, if we take aluminium exhibits +3 oxidation state, but with heavier metals +1 oxidation state gets progressively stabilized. See, common oxidation state of aluminium is +3. But with heavier metals, what happens is it shows +1 oxidation state. This gets progressively stabilized on going down the group. So on going down the group, this gets stabilized. So this is called, this consequence in a group, this is called the inert pair effect. So explain it clearly and write the example also clearly. And next question, define allotropy. Name the various allotropes of carbon. So allotropy is the existence of a metal in 2 or more different forms or states. Existence of an element in 2 or more different states. This property is known as allotropy. And for carbon, we can see allotropes such as diamond and graphite. These two are 2 allotropic forms of this carbon. And next question, what are silicons? Silicons, what is silicon? A silicon is a polysiloxane. These are polymers made up of siloxane. Siloxane is a compound between silicon and oxygen. These are typically colorless oils or rubber-like substances. These are polymers which have a monomer of siloxane, and they have examples like these are colorless oils or rubber-like substances. These are known as silicons. And next, what is classical smog and what is its chemical character? So the smog is formed from a mixture of smoke and fog. This classical smog occurs in cool, humid climate, and it is a mixture of smoke, fog and sulfur dioxide. Mixture of this smoke, fog and sulfur dioxide is known as classical smog. Chemically, it is a reducing in nature. It is a reducing compound. And next, IUPAC names. This is also one of the important questions you can expect in 2 marks. So write the UPSC name of CH3 taken thrice, C, CH2, C, CH3 taken thrice. First write the formula. Formula is given, right? Expand the formula in your understanding way. See here, for this middle carbon, for this carbon of the outside the bracket, this is linked with 3 CH3 groups. This carbon is linked with 3 CH3 groups. You can see in this diagram. In this expanded formula, this carbon is linked with 3 CH3 groups. In the middle we have CH2, and the same is repeated for the last carbon also. So now see which is the longest chain. The 5-membered carbon chain is the longest chain. So name the compound now. Since it is a 5-membered longest chain, pent-ane will come as the parent chain. So at which positions we have methyl groups? At 4th and 2nd and 4th positions we have methyl groups. Completely how many methyl groups? 4 methyl groups. So it is tetramethyl. Tetramethyl. At which positions? 2 and 4 positions. Since it is twice, we are writing 2, 2, and 4 at 4th position also we have 2 methyl groups. So we are writing it as 4, 4. So 2, 2, 4, 4, tetramethyl pentane. Next question, CH3 taken twice, C, C2H6 taken twice. So if you expand this formula, you can see here CH3 taken twice. This is CH3 taken twice, 1 CH3 here, 1 CH3 here, and C2H6 taken twice, C2H5, not H6, H5 taken twice. So this is C2H5 taken twice. If you expand it, this is CH2 and CH3, that is C2H5, and this CH2 and CH3, they are C2H5. Now identify the longest chain. This L-shape chain is the longest chain. So number it. So there are 5 carbons. So pentane. At which position 2 methyls are there? 3rd position we have 2 methyls. So 3, 3. Dimethyl pentane is its UPSC name. And next, tetratertiary butyl methane. So this is little typical, but if you understand it, you can write it easily. For 1 carbon, we have 4 tertiary butyl groups attached. If you apply the same, the longest chain, identify the longest chain and write the chemical name, you will get the name as 3, 3 tertiary butyl, 2, 2, 4 tertiary methyl pentane. This becomes the IUPAC name. You can take any of the longest chain because all are the similar. So take this one. So this as the longest chain, and add the substituted added methyl groups and tertiary butyl groups in the IUPAC name, so you can easily answer. And next write the structure of the following compounds. So previously we have IUPAC names, now it is structure. Trichloroethanoic acid. Since ethanoic acid is there, we have 2 main carbons in the parent chain, acid COH functional group, trichloro, 3 chlorine groups will be present. So this is the structure. Next, neopentane. So it is having this 3 carbons in the parent chain and 2 methyl groups are attached to the middle one. Next, para-nitrobenzaldehyde. You can see the positions: ortho position, meta position. This is para position. At para position we have nitro group and it is a aldehyde on benzene, that is CH4. This is the structure of para-nitrobenzaldehyde. So these are few important questions of these very short answer questions. So prepare well and all the very best.